So the first one is 36 minus 7x over x times x minus 3 quantity squared.
Yeah, this is slightly different.
Mm-hmm.
When you have something like this, you have to allow for an x minus 3 and an x minus 3 squared.
Mm-hmm.
Okay, so it's going to equal a over x plus b over x minus 3 plus c over x minus 3 squared.
Okay.
I believe. And I don't think you have to have an x.
No, that's correct.
Yeah, I don't.
It's like that's what I remember in
It's not
class.
like the irreducible quadratic. If you have an irreducible quadratic, then you need to put the x and the constant in that numerator of the third term. But, so now what's the next line? In other words, notice that if you look at those three denominators and you had to figure out a common denominator, it would be that.
Yeah.
In other words, it wouldn't be x minus 3 cubed. You don't just multiply all three denominators together. Because we have
No.
an x minus 3 and an x minus 3 squared, then the x minus 3 squared is the common denominator between those two terms.
Mm-hmm.
All right. So now let's see. The a term is going to multiply by these two terms. Let's see. I think that's correct. Yeah. No. The a term is going to multiply by that only.
Mm-hmm.
And let's go through that logic in case you're confused about it at all.
Okay.
If I'm adding these three terms, let's look at it from that perspective. Well, my common denominator is going to be this.
Okay.
Which means this term here has to be a times x minus 3 squared because we can't change that fraction. So whatever we end up with has to equal a over x.
Okay.
Okay, so that's why it's important that you see what the common denominator would be if you were adding these three fractions. Because I almost made a mistake and automatically assumed that it was going to be a times that, which it normally would be. In other words, if you had three different linear factors, then the common denominator would be the product of all three. So this is a bit of an unusual case. What's this term right here going to be?
B times x and x minus 3.
Yeah, in other words, we just have to make sure that it's equal to what is above it. And that
Mm-hmm.
is. And over here, the C,
It would be the same thing, x and x minus 3.
just X.
Oh, just x?
Yeah, notice that my goal is to not to change it. I got to end
Oh,
up
okay.
with that. Okay, well, if I put just CX, the X's cancel, and I end up with what I started with.
Okay.
Okay, that's why I kind of like this method, is it makes it really easy to verify that you're not changing anything.
Okay.
Whereas if you don't do it this way, it's pretty easy to make a mistake, as I almost did. Okay,
All right.
now I can say that numerator is equal to 36 minus 7x.
Mm-hmm.
So now let's see if we can use that technique. We might be able to. If I let, yeah, I think we can. What am I going to let x equal to try to solve for a, b, and c? What's a good thing to start with?
Um, I don't know if it's 0.
Okay, 0 is good because it makes this term disappear and it makes this term disappear. So
Mm-hmm.
you end up with a times negative 3 squared equals 36, right? 36 minus 7 times 0.
Yeah.
Okay, which is 9a equals 36. So a equals 4.
Okay.
Okay, now we can go back up and write in. We've solved for a. Let's put it in there. Now, what's another thing that we could let x equal that would rid us of some of these things?
3.
Good. So that'll take care of this first term, it'll take care of the second term, and we'll end up with 3 times c equals 36
Mm-hmm.
minus 21, 15. This is
Okay.
actually the preferred method if you can pull it off. Um, what did we end up for A4? Right, and
Yeah.
C is
Mm-hmm.
5, so let's go ahead and put that in there. Now,
Okay.
solve for B. Let's see, how do we solve for B? Since, let me think for a second. I think we can make up any other number. Yeah, in other words, I can make up any value I want for x other than 3 and 0. Substitute it, and there's only going to be one variable, b. So let's let x equal 1.
Okay.
Okay. The left side will be 36 minus 7, 29. The
Mm-hmm.
right side will be minus 2 squared, which is 4 times 4, 16,
16.
plus
B.
minus 2b,
Yeah. Minus 2b.
plus 5. Now if I take
Okay.
2b on the other side, bring all the numbers to the right, I get 21 minus 29 minus 8, b equals minus 4.
Okay.
Okay, so I believe this method can be used whenever you do not have an irreducible quadratic. In other words, we found that the only thing that we couldn't use this method on was, here's where I should write it, was when you end up with a bx plus c in the numerator.
Okay.
That's 4, that's minus 4, and that's 5. And if you went back, again, if your life depended on it, on this being correct, you would go back and do this. You would add these 3 fractions together and
Okay.
make sure when you're done that your numerator reads 36 minus 7x.
Okay.
All right, what else?
36. Okay. Another one of those.
Okay,
I have x cubed plus 2x squared minus x plus 1 over x squared plus 3x minus 4.
x squared plus 3x minus 4.
Yeah.
What's the first thing we're going to do?
See if we can factor.
Which side, top or bottom?
Bottom and top, maybe?
Well, if you could factor the top easily, I might try to do that, although not really. You really don't want, if you think about how we solve these, we end up with the right side of the equation being these things. You wouldn't want it factored. You'd want it multiplied out. You'd want it in standard format.
Mm-hmm.
But what's important is to factor the denominator, because that's going to put how many terms we're going to have. In other words,
Okay.
if you factor the denominator, one of those terms is going to go there and one of them is going to go there. Well,
Okay.
how's the denominator factor?
X plus 4 and x minus 1.
Uh-huh. So that's what's going to go over here. Okay. Now see if you can do the rest of it without me saying much.
Okay. X cubed plus 2x squared minus x plus 1 equals ax plus bx minus a plus 4b. Oh, sorry.
Are you, I don't know if you're going step by step or you've already done it and you have a final answer that you're reading.
Oh, no, I'm doing it on my paper, sorry.
Okay, so let's just back up one step. What goes with the A?
Ax minus, or a. So it'd be ax minus 1.
Right, let's write it like that, just as
Okay.
an intermediate step. And what goes with the B?
X plus 4.
Yeah. I mean, if you were looking back on this, trying to figure out what you did, this would be a good thing to be looking at.
Okay.
Now you can combine them.
Okay.
So
And it'd be ax plus bx, or ax minus a.
no, hold on a second. Let's back up a step even. Do we need to combine these? Think we have a problem. You can tell we're going to have a problem, right? Because I'm not going to end up with an x squared term on the right, let alone an x cubed term.
Is this one of the problems where we have to divide it by the...
Yes, exactly. What I failed to spot when I first looked at this was that the numerator was a higher degree polynomial than the denominator. So that's the first thing we have to do. Let's do that. And the way to do that best is to back up, take the original polynomial, divide it into this polynomial, and you're going to get a linear factor because it's exactly 1 degree higher, and you're going to get some remainder. And it's the remainder we're going to work with in terms of the partial fractions.
Okay.
Okay? So, these partial fractions, boy, they're like 4 or 5 different types of problems, aren't there?
Yeah.
Had all of them. So what's this first term?
It would be x.
And then multiply it back. Now you multiply the x times all 3 terms.
3x squared minus 4x.
Now you
subtract it.
What do you get?
So it'd come out to be negative x squared plus 3x.
Bring down the remainder. Always.
And then it'd be minus 1. And yeah, negative 3x plus 4.
Okay.
And if you subtract that, you get 6x minus 3.
Yeah. So really what we're looking at in that original polynomial is the following. X minus 1 plus 6x minus 3 divided by this, and now we're going to factor it into x plus 4 times x minus 1. You with me?
Okay, yeah.
Okay. Let's erase all of that so it's not in our way. Now, like I said, the only time that I know of in math where you have to do this is when you're integrating. Okay?
Okay.
So if I had an integral there, well, I can take the integral of that really easily, but I cannot take the integral of that very easily. But if I could separate it into two partial fractions that are added or subtracted, then I can. So
Okay.
we're going to not ignore the x minus 1. We're just going to leave it set aside and not deal with it in our partial fractions. We're going to deal with just that part there.
Okay.
Okay, so this is going to be a over x plus 4 plus, it's always plus incidentally, regardless of what signs are there. And then if b comes out to be negative, that's a different story. But okay, now we can say that 6x minus 3 has to equal a times x minus 1 plus b times x plus 4. Now you see what I did there? I didn't even bother to put the common denominator in it. When it's a simple one like this, it's always that. It's always a times that denominator plus b times that denominator.
Yeah.
Okay. Now we can use our little technique. So help me along here.
Oh, are we talking about the one where we do the zeros? Okay.
Yeah, where you try to solve for the a and b by letting x equal certain values.
So we could let x equal 1,
Okay.
and that would cancel out a.
So when x equal 1, give me the equation.
It would be 6 minus 3 equals b5.
Uh-huh.
5b.
b equals 3/5.
Mm-hmm.
Okay, now how do we solve for a?
We could set x equal to -4.
Mm-hmm. So
And that would cancel out the b. The 6 would become -24 minus 3, so that'd become -27 equals -5a.
Uh-huh. So
Okay.
a equals 27/5. I remember these two answers.
Oh, what to do with them?
Well, no, I mean, I remember this problem. I don't know if it was you or with somebody else, but I remember coming up with solutions of 3/5 and 27/5. In fact, what it may have been was this as a partial fraction problem all on its own. I think that's what it was. In other words, this was a little different. This was, you got this remainder after doing the long division, and then you still have to apply the partial fractions. So let's see. If a is 27/5, then that's 27/5 like that. Got
Okay.
it? And if b is 3/5, then it's 3/5. And the answer is x minus 1. Here's the full answer for the results of that partial fraction. Here, the easier way to write it is like this. since I've already written that part. There you go. That's the,
Okay.
okay? And the beauty of that answer is I can now integrate that, I can integrate that, I can integrate that, and I can integrate that relatively easily. Whereas integrating it when it was multiplied together in the denominator was just impossible. That's why they came up with partial fractions to do these.
Okay.
Okay? But you can't throw away the x minus 1. In other words, that's part of the solution also.
Okay.
The solution is not just the partial fraction part.
Okay.
All right.
Okay.
What other kind of curveball do you have? I didn't know there were so many different partial fractions to work.
Yeah. I think this one's
Your level of pre-calc that they're giving you all these.
What? Sorry.
I said I'm shocked that at just in pre-calc you're getting all of these.
Yeah, there's a lot.
You don't get partial fractions in calculus until Calc BC.
Oh, wow.
And then maybe there. Maybe not even till Calc 3.
Huh.
They don't even come up. But I guess they are in Calc BC. Yeah, if you take the AP exam, there's partial fraction questions on the AP Calc BC exam. But
Okay.
I don't think there's any that are any harder than the ones you're giving me. I might just be not remembering it. It's been a while since I tutored somebody taking Calc BC, but all right, what else?
10x plus 2 over x minus 1 times x squared plus x plus 1.
Again, that is an irreducible quadratic, I believe.
Mm-hmm.
How can you tell really quickly?
The middle coefficient is positive and the...
Analyze the discriminant. Discriminant. Okay? What's the discriminant?
Okay.
That's b squared minus 4ac. The part that's inside the radical sign.
Okay.
If that comes out to be negative, then that's an irreducible quadratic. If it comes out to be 0 or positive, it is not, meaning I can factor, even if I have to use the quadratic formula. But in this case, you get what? 1 minus 4 comes out to be negative.
Okay.
Okay. Now maybe you had a quicker way of doing that. You were kind of doing it when I interrupted you. Is it different than analyzing that? You were saying something about the middle term?
No, not really.
Okay. I can never tell when I look at those immediately whether they're irreducible or not. They tend to be irreducible if this is a plus sign with the constant. If it's a minus sign, they're never hardly irreducible. Because notice that term would end up minus, and then it's minus a minus, so it's a plus. So you're going to have a plus discriminant if that constant is a negative. Not always, but most of the time. So we know it is an irreducible quadratic, and that's the first step. So what do I have to put over on the right side?
A over x minus 1 plus bx over x squared plus x plus 1.
Isn't it bx plus c?
Oh, sorry, bx plus c over x squared plus x plus 1.
Okay. Now, when we do these, I don't think we're going to be able to use that technique. However, again, it's going to be A times that plus that times that, right? So
Okay.
let me speed it up a little bit and I'll distribute it. Plus AX plus A plus, what's X minus 1 times BX plus C?
Bx squared plus cx minus bx minus c.
Okay, combine all like terms.
So ax squared plus bx squared.
I'm going to write that like this.
Oh, a plus
I'm going to
bx
factor
squared.
out the x squared, but I'm going to put it to the right instead of to the left.
Yeah.
Okay, that takes that.
Plus a minus b plus c x.
Okay, gets rid of that,
Uh,
that, and that.
plus a minus c.
I'm going to put parentheses around that,
Okay.
just for clarification. All of this has to be equal to 10x plus 2. Now, I think you can kind of see why we can't use that method before. In other words, if I set x equal to 0, is all I get is a minus c has to equal 2. I don't get it.
Yeah.
I'm not able to solve for a, b, or c by doing any of that. I guess I could end up with a bunch of simultaneous equations, but I can get to simultaneous equations a little faster. So what's the next step?
You set a plus b equal to 0.
Okay,
This is like figuring out the like little equations.
right, exactly. What we're doing here is called equating coefficients. In other words,
Okay.
there's an x squared term on the left, but its coefficient is 0. What's the next one that we can write?
A plus c minus b is equal to 10.
Okay.
And then a minus c is equal to 2.
All right. Now, that's 3 equations and 3 unknowns. So I know I'm going to be able to solve it. Let's see. What's the best way to do it here? Let's see. I guess I can say A. Let me think about if we want to use elimination on this. Let's see. I could get rid of the A by subtracting these two, and then I can get rid of the A by subtracting those two. So I'm inclined to think that elimination is easiest.
Okay.
Okay, rather than substitution. I could fool around with substitution, but I think it's going to be a lot of complex algebra. Whereas, let's number these. This is equation 1, 2, 3. Right off the get-go, I think I want to take 2 minus 1.
Okay.
That'll get rid of A, and it'll leave me a positive number on the right side.
Yeah.
Okay, so what do I get? For equation 4, I get
2 minus 1, c minus 2b equals 10.
Okay, and then we need to eliminate the same variable for equation 5, and I'm going to work with 2 and 3.
And 2 minus 3?
I think so. That'll leave that same positive number on the right. So
you're going to get 2c minus b equals 12. Or equals 8.
okay. Now we have to manipulate 4 and 5 in order to eliminate another variable. In other words, now we're down to 2 equations and 2 unknowns.
Yeah.
So how should we can multiply either one of them by 2.
Yeah, you could multiply the top one by 2.
Okay, so rewrite 4 as 2c minus
4b equals 20.
And I'm going to put a line through it so I don't accidentally misread it. Now let's do 4 minus 5.
You would get 4 minus 5. Negative b plus, so 3b.
I think it's negative if we do 4 minus 5, because it would be minus 4b minus a minus b.
So it'd be negative 3b.
Yeah, negative 3b equals 12.
Yeah.
So b equals
negative 4.
Now we have to go backwards through our equations, and let me erase the line that's through that, because that's generally, we're not going to want to solve for c by plugging into the new 4. They're bigger numbers.
Okay.
Okay, so if I'm going to draw a line through anything at this point, it's that one. I'm never plugging into that one, because that 4 is the same as this 4, and this 4 has a lot smaller numbers. So let's solve for c using 4, because 5 has a 2c. So 4 makes more sense. 4 will be at most one more step to solve for c.
So 4 equals c, and this is plugging in d. C plus 8 equals 10.
So c equals
2.
Okay. Now let's go back to one of the first 3 equations to solve for a. Which one?
You could plug in c to 3.
Okay. So what is a?
And then minus 2, so plus 2. A equals 4.
Okay. And that's, so we have 4 minus 4 and 2. And that's 4 minus 4 and 2.
Okay.
All right.
Okay.
I wonder how many levels of partial fractions there are. In other words, you've already presented me with 4 or 5 different types that you have to do completely different ways. I know, let me just give you another one. If I had, say, 1 over x minus 2 cubed, you have to have 3 terms on the right. You have to have x over x minus 2 plus b over x minus 2 squared plus c over x minus 2 cubed.
Okay, I'll order it. Just come home and I'll order it.
Okay.
Okay? And so whenever you have a linear term raised to a power, you have to have every one of those degrees as a denominator. Because it might be like that. In other words, if I gave you these 3 fractions and said add them together, your common denominator is x minus 2 cubed.
Okay.
Okay? And so there might be an x minus 2 squared denominator or an x minus 2 denominator. So you have to allow for all combinations. Hopefully you don't get a problem like to the 13th.
Oof, that would not be fun.
No. All right, what else do you have?
Let's see. Well, that's pretty much for my homework.
Okay.
I can see if I have any SAT questions right here.
I can pull up a site that's got the new SAT on it. Let me show it to you. You might find it useful.
Yeah, we could do like a little bit of that.
Yeah.
Are there any problems there?
Let me bring it up. In fact, I got a practice test 1 and 2. Yeah, I have no idea what else you might be working on besides partial fractions, because that's such a almost a unique math discipline that
Yeah.
I don't know where that even comes. I'm not sure what you did before or what you're going to do next. It won't be partial fractions. In other words, you won't encounter those again for 2 years at least. Let's see, I need to go. This is from the College Readiness Board, which is the organization that makes the tests.
Okay.
So I cannot imagine a practice material that's any better than this.
Okay.
Like most of them, they give you those formulas. You don't need to memorize those. Although you should definitely familiarize yourself with each one of these. Make sure you know exactly what each one is talking about. You know.
Yeah.
All right. Well, I'm not sure these are necessarily in order of degree of difficulty either, like most SAT practice tests are. So I don't, with a lot of people, I'll start on problem 30 just because I want to work on the hard ones. But I'm a little reluctant to do that with these. Well, let's just start at 1 and see how much trouble it gives you. Let me open up my other page here. Hold on a minute. Let me snap that left, put that there. Can you still read it okay? Here, I can blow it up a little bit.
Yeah, no, I can read it okay.
All right.
If x minus 1, k equals 3, so you set 3 equal to k, and then I can see right off the bat you can divide by 3. So x equals 2, because then you take the 1 from x minus 1 equals 1.
Be careful. You're making kind of a common mistake.
Okay.
You're not going to divide by 3. You're going to multiply by 3.
Oh, okay.
Right?
Oh, yeah.
You could divide by 3, but that gives you x minus 1 over 9 equals 1, which doesn't really help. In other words, the goal here is to come down and solve for x. And the way you do that is you get rid of this denominator by multiplying by 3, and then you get rid of this minus 1 by adding 1. So
and x equals 10.
X equals 10, yeah. Okay. Imaginary numbers. What is 7 plus 3i times, oh no, just plus, not even times.
Just adding them? It would
add
be
the real part, yeah, add the real parts, add the imaginary parts. It's that easy.
It would be -1 plus 12i.
Correct. Okay.
On Saturday, Armin sent M texts each hour, each 5 hours for 4. Sent T texts each 4 hours, which of the following represents the total number of messages sent by Arlen. Sent M text messages each hour for 5 hours. So that'd be M5. And Tyrone sent P text messages each hour for 4 hours. So that'd be P4. So 5N plus P4, 4P.
Yes. Now, the way you did it is the best way to do it, if you can do that. But I've seen these kind of problems where there's a combination of multiplication and division, And as soon as they do that, it becomes very difficult to keep the logic straight, at least for me.
Okay.
So let me use this as a perfect example of how to do it by picking numbers. Even though you did it the most efficient way, if you did not know how to come up with that, whenever you see a problem that has variables in the question and variables in all four answers, that's almost always an opportunity to pick numbers. In other words, you can let P and M equal whatever you want. I could let M equal 2 and P equal 3. I'm just making up numbers, okay?
Okay.
Now, can I tell what the answer is with those two? Well, sure. When M is 2, then Armand sent 10 text messages, and if P is 3, Tyrone sent 12, so the total messages were sent were 22. I can figure that out. Now I'm going to go through each of these four answers using an M of 2 and a P of 3 until I get 22. Notice the first one is 54. This one is 120. This one is the correct answer, 22. This one down here would be 8 plus 15, 23. So even without being able to put it into the formula directly like you did, I could still work it out. And the kind of problems I'm talking about are ones where you might have an M times, maybe you'd have an M plus P, but the whole thing would be divided by an X, maybe 100X. Maybe you're going from percentage to decimal also. So if this was the answer, you can imagine the message would be somewhat difficult to come up with that. And so it's only on the super hard ones where both multiplication and division, usually if it's just multiplication or multiplication and addition, they're not that hard to come up with the way you did it. But I've found that if there's a combination of multiplication and division, it's very tough for me. And the way I end, if my life depends on it, I'm going to pick some numbers and make sure I find the right answer.
Okay.
Okay? All right, let's go down to number 4.
Okay. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. Number of phones she's left to fix below. Equation. P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked. What is the meaning of 108 in this equation? Number of phones left and equation.
And here is where it's really worth looking at the answers. You always want, on difficult problems, you always want to take a gander at the answers before you attempt to solve it. Because,
yeah, I just started looking at those actually.
Yeah, and it gives you an idea of what they're looking for.
And so I think it's B. Kathy starts each week with 108 phones to fix.
Yes, because if D was 0, which is what it would be when she starts the week, got 108. And as she works, she does 23 a day. After day 1, she's got 108 minus 23, and so forth.
Okay.
Okay. Hold on. Okay, number 6. Yeah, we got time for 6 and 7. I want to get to 7. 7's kind of a clever one.
Okay. 6. A pediatrician used the model above to estimate the height of a boy between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of the boy's height each year? is age A? 3 inches a year? A?
Yeah, the slope is what they're saying.
Yeah.
In other words,
I think
the rise over the run is how much he grows each year, and the run is per year, 1 year. So, all right, let's go look at this tough one, tough looking one up here. Hold on, I gotta get to the.
No worries. Okay. The formula above gives the monthly payment M needed to pay off the loan of P dollars at R%. So M equals monthly payment P equals dollars and R equals percent of annual interest, and N is months.
Now, all of that ended up being wasted time.
Okay.
This problem has nothing to do with you understanding what each of those are.
Okay.
Okay? Not that I blame you. That's what I did, I think, the first time I saw it. Let me just make sure there's not a fifth answer down here. Yeah, there's only 4 answers. Okay, good. Whoops. Let me make sure I get all 4 of them visible. There. How would you solve for P here?
Are
That's what they're asking you to do, is solve that equation for P.
they multiplying everything by P too?
Well, how about we multiply everything by the denominator and divide everything by the numerator?
Okay. So
It actually the thing you do not want to do is get involved with trying to multiply these together. That leaves you into a quandary where you would not you wouldn't know where to go.
Okay.
So we just want to multiply. In other words, here's a P over here. Here's the M. So we're going to multiply the M by this entire denominator. Well, do we see that anywhere? We do, right?
Oh, it's yeah, B.
Okay. And then we're going to divide by both those to get rid of those. And that's what's there.
Okay.
So B is the answer, and the problem actually was pretty easy. It was just complicated. In other words, it was basically saying M equals A times B divided by C minus 1P. You'd solve for P by multiplying both sides by C minus 1 and then dividing by A times B.
Okay.
Okay? They just tried to confuse you by making all of those difficult looking. That's actually an easy problem. Now, I would, between easy, medium, and difficult, I would say this is easy.
Yeah.
You just have to see it. If you don't see it, then it's difficult.
Yeah.
Okay, number 8, still no calculator here.
If A over B equals 2, what is the value of 4B over A? So A would equal, does A equal 2B?
Uh-huh.
So the value of 4B over 2B equals 2.
Correct.
So C?
Yeah. I was doing it a different way in my head. Maybe it's worth pointing out. I don't know. You did it about as efficiently as you can do it. But if A over B is 2, what's B over A?
1/2.
Yeah, the reciprocal of 2.
Okay.
If B over A is 1/2, 4B over A, I'm going to multiply both sides by 4.
Oh, I see.
Equals 2.
4 over 2, 2.
Okay. But the way you did it was just fine. there will be problems where you will not be able to solve for an individual variable. In fact, this is one of them. You weren't actually able to solve for A except in terms of B. So a little trick like this is worth knowing, that, you know, if you know A over B is 2, you also know that B over A is 1 over 2.
Okay.
So it shouldn't give you
Okay.
a problem. You want to skip it? We've already
Oh yeah, we can skip it. We've been working on these.
equations today, so I'm sure you know how to do that one.
Yeah.
There is one thing different about this. What is it? They're not actually both in standard format. The first one is, but the second one's got the y in front and the x afterwards. So you'd want to reverse those. Make it minus x plus 2y before you proceed. Okay? In other words, I guess it'd be easy enough to solve this either way. I probably multiply both sides by 3 and then add the two equations. Get rid of the x. And also notice that all the answers have 4 different x values, which means you're only going to have to solve for one variable. Ah, that's interesting.
Okay.
2 of the answers have the same y value. So which variable should we solve for?
X.
Yeah, there is a little trick to this problem. If you solve for x, you do not have to solve for y. Whereas if you solve for y, you're still going to have to solve for x because there's 2 minus 6's.
Okay.
Okay. So they got tricks up their sleeve on this thing for sure.
Okay.
And that's, you could still solve for y and get the right answer. It's just it would take an extra step. You'd have to solve for both variables. But
yeah.
That's another case where it's worth looking at all the answers before you attack the problem. If you happen to notice that, then you'd know which variable to go for.
Okay. So for the functions g defined above, a is a constant, g4 equals 8. So what is the value of g? Negative 4. Negative 4, g negative 4? Huh. Don't you just plug in negative 4 for x?
Well, yes, but first you're going to have to solve for a.
Yeah.
That's the key here. And you can kind of count on most of these being like that. You're not going to get very many problems where you're just going to be able to plug in a number and come up with the answer. In other words, let's start with this information. What would g of 4 be? How would I solve for g of 4? Just looking at the top thing. What's that equal?
You would plug in 6, so it would be 16a plus 24.
Well, they've told us that that's equal to 8. That allows you to solve for a.
Okay.
So a is going to be minus 1. Now you know what the equation is. The original equation is minus x squared plus 24. And now g of minus 4, you can solve for it. What is it?
Okay. 16 squared minus 16 plus 24. Doesn't g of negative 4 equal 8 too?
Yes. In other words, this is a minus 16 plus 24. 8 is the answer.
Okay.
Okay. But you couldn't have gotten there straight away. If you plug in negative 4 immediately, you get You get 16a plus 24 equals g of x, but you can't really go anywhere from that.
Yeah.
So definitely a case where you have to deal with the first information. In other words, you can almost be certain you got to do something with that before you can solve this problem. Not that they're beyond giving you problems and irrelevant information in the problem. They certainly are capable of that. But this doesn't look like one of those cases. This looks like you have to use this information to do something before I can solve for this over here.
Yeah.
All right. Let's go look at 11. So far, how's the degree of difficulty on these compared to the practice one you took or you have?
A little harder, but not too bad.
Yeah, these seem relatively hard, but like you said, not too bad.
Yeah. So this will probably be like the last one.
Yeah.
In the equation above, B and C represent the price per pound in dollars of beef and chicken. Next bar, what is the price per pound of beef when it is equal to the price per pound of chicken? Don't you just set these two equal to each other?
Exactly. And then you have one equation, one variable, you can solve for it.
Okay, so it'd be, whoops, 235 plus 5x equals 1.
So let's see, what do we end up with? We end up with 410 plus 0.65x. Excuse me.
Yeah.
Gotta subtract them. Let's see, we got that equals that, so we end up with 0.6 on the left and 0.15x on the right. So x equals whatever 6 divided by 0.15 is. Ooh.
Is it 6 divided by 0.15 or is it 6 multiplied by 0.75 or something?
Hold on, let me just, what's 0.6 divided by 0.15? That's 4. That answer is not on there. I must have done something wrong here. That's why taking a shortcut sometimes will just lead to mistakes. Well, I definitely get 0.6 on that side, and over here I get 0.15x. What am I doing wrong? B and C represent the price per pound. What was the price per pound of beef? What was the price per pound of beef when it was equal to the price per pound of chicken? X is equal to 4. That's not what they asked.
Oh, and then you plug in 4.
Yeah, it's got to be 335.
Yeah, okay.
In other words, you plug it in there, and the 4 times the quarter, that becomes 1. 235 plus 1.
Oh, yeah.
Tricky little devils. But if they really wanted to be evil little devils, they would have put $4 on there as one of the answers.
Yeah.
Because then half the people would have missed it. I would have missed it. I would immediately just stop once I solve for X and I see it as an answer, and I would have gone from there. All right.
Okay. Well, I think that's it.
Okay, Nicholas, I will talk to you next week. Let's see, you have a session scheduled for next week?